Hi, everybody, and thanks for being here. I hope you all are enjoying the great conferences today. Today, this talk, I want to summarize our experience and vision in building some AI products and projects. I'm not going to be focusing on very low level, but I'm going to be following a specific example on building a natural language processing product, or a chatbot, or a bot. So let's keep starting. First of all, let me just talk to you a little bit of the current landscape. As you may know, and we all know, all of us as users of technology have become so demanding, and we have very high expectations in terms of these services and products, and us, not only as people, but as companies, customers, employees, partners, stakeholders, et cetera, et cetera. We say that we are very much embedding to deep digital journeys, and people, we don't have a durable affinity with specific platforms like mobile, desktop, or any other. But we're rather expecting frictionless environments and moving from platform to platform anywhere, anytime. And we want to obtain very personalized services, and we're even willing to give away a lot of data in order to get this. In other words, we're eager to create emotional ties with brands, and in turn, we're being willing to increase our loyalty to all of these brands. But most importantly, the most important feature to highlight in this current landscape is that we today are living in a very important time because we are experiencing a digital and a cognitive revolution. So let me introduce you to Globant a little bit. Globant, the company, it's a multinational technology services company with close to 7,500 employees in around 38 offices around the world, 13 countries. And we are all, as technicals, in Globant, we are part of what we call studios, which is a concentration area. And for example, I'm part of the artificial intelligence from the strategic tier, and also I've been part of big data from the specialty. Just to mention, we were named leaders of digital consultant services by IDC from 2016 and 2017. And you may have probably not known of us, heard of us, but you most certainly have interacted with some of the products that we helped to build. And we have been a business case study at Harvard, Stanford, MIT, because of the great and fast growth of the company. And just to mention some of our clients, Google, LinkedIn, EA on video games, Coca-Cola, and most of the big players into retail, banking, insurance, technology, media, video games, etc. But I'm not here to talk about that. I'm here to talk a little bit more on how we do things, and specifically how we do AI. And first of all, starting from a little bit higher level, we do Agile, but we do our own Agile. And just to summarize it, we use what we call Agile pods, which is a small multidisciplinary teams that self-contain and are self-sufficient and create their own metrics to measure the evolution on projects. And typically, in an AI project, as an example, we have, of course, a data scientist, we have data architects, and we have people from UX. And depending on the specific application, we have some other people, like from big data, for example. But let me talk to you as a core part of our methodology. I wanted to highlight the AI experimental iteration. As you may all know, AI contributor or data scientist always lives in the middle of business and technology. And why business? Because we envision and help to define the project's objectives. In the case of AI, based on an understanding of how both users and machine work. And why technology? Because we want to make sure that the idea happens and it gets translated into the development and mature of data-driven product, automated product. Let me go back a little bit. Let me talk a little bit on these iteration phases. We usually start with a data-driven discovery, which is understanding, learning, and read from the raw material, plus how the business works, and then manipulate it and help and start creating MVPs or start building a product and then validating this product, both quality and the proper applications of the models to create it, and then always facing to scale. Because as one author said, the real value of big data is when you get it to production. And how do we put our methodology that you see on top with a CRISP or methodology that it's well known? Well, it goes like this. We start everything from a business understanding and helping define, as I mentioned before, the objectives in a more quantitative way as possible in order to make sure we're going to be always measuring the advance of and the maturements of the model. And then, of course, big part of it is understanding the data, getting the data both internal and learning what external data we could imply. And then, of course, preparing it, massaging it. They say that a data scientist or AI contributor spends up to 70 to 80% of its time working with the data. But the thing of it is the modeling part. The modeling goes very side to side with evaluating. Whenever we create a model, we have to have a framework to evaluate it as well in order to make sure we are getting ready through these iterations. And then deployment, always thinking on big scale, always thinking on deployment, sometimes on the cloud, sometimes on premises, but always on big scale on how we could enhance it. The thing to mention here is that we don't want to do this step one after the other necessarily, but we want to go back and we want to circle back from deployment, perhaps to understanding or evaluating the model and to getting more data, and then work again and modeling and go back again. Now, let me talk about how we apply this methodology into a specific problem. Just please bear in mind that this is an example application, but the whole methodology and even probably the model may be applied to some other problems. We start with the data-driven discovery, and we're going to talk about this company that provides mentoring to customers to develop certain skills from a very specific field, let's for example, math. And all this communication or this mentoring is via chat communication. There are some challenges here. The company knew that we could help them with AI. It's very obvious, okay, build a chatbot or something, but there are some specific challenges of this, like, well, as I mentioned before, it's a constant two-way communication. Assistants need to guide the customer or the client to work on their solutions, but not to give away the solutions itself. Just help them learn to build their own solutions, because they need to test and learn the techniques that they previously learned. Of course, there's always confusing needs from customers. There's always confusing questions on these chats. And sometimes even the assistants need to refocus or the conversations, or we may have found off-topic conversations. And as I said before, they thought we could help them with AI, and typically when a client approaches, the situation is that we want to do machine learning, we want to do AI, but that's when we come up and we help them define a specific objective that may uses AI, may uses technology, but the objective is higher level. We want to accomplish something, and we want to develop a product. More than only using AI. Out of the discovery, we plan to create a chatbot to help to assist the response, to help to assist the assistants to respond in a more automated way. We're looking to build a product. This is very important, not to replace human interaction, but rather to enhance it. So it's all about boosting assistants' productivity. Build a working bot able to respond and to maintain this threaded conversation with the students and provide guidance towards finding answers to a problem without actually giving the answers. So the bot works as an assistant, as an aid to leave assistance more. And more than that, the company was trying to find a higher level methodology to serve as a experimental and template on how to tackle this type of task and providing a way to manage development, best practices, team collaboration, and so on. I know that the data preparation, as I mentioned before, takes a lot of time. But for this talk, I'm not going to spend too much time on this because we could have a session on its own about this. So I'm gonna go directly to a little bit on the implementation or how this chat would work. We knew, of course, they knew, and we knew that machine learning or deep learning. We could solve this with a machine learning or deep learning problem, but it's not only because we're talking about a lot of data, but rather because we want to train and program and to learn how to respond, which means learn by example rather by instruction. And we thought of this as a machine translation problem because usually some other deep neural networks both the inputs and outputs are fixed, like in the case of images, but in this case, we're talking about sequence to sequence because we have a phrase and we want to return a phrase as well. So we thought as a machine learning translation, and more specifically, we use LSTM neural networks architecture. And we needed this framework. We wanted to use a framework because nobody wants to start from scratch, or we needed a framework, and we needed to be flexible for experimentation. We needed to be scalable, and that's why we decided to use this implementation OpenMNT for PyTorch specifically. This is a full feature open source from MIT, neural machine translation system. As I mentioned before, on Torch specifically, mathematical tool, of course. It's very high speed and optimized in memory for GPU training. And simple, it's simple and general purpose, but most dedicated to translation. So we needed to create or to map it a little bit to what we do, a chatbot. And for the part of where to run it, we try different cloud services, but we found FloyHub, which is a cloud solution specifically for deep learning that fires up GPUs. So we needed to do start iterating on the model itself, and we needed something that isn't very expensive and that it's agile And because of that, the first thing to do in order to start training our models or to start training our neural networks, it's find a way to train with less data, not all the data. We don't need all the data in the world. We have probably 10 million records or chats, but we didn't need that in order to tune the hyperparameters. So the first task to do was to find a meaningful data set. And in this case, it was around 30% of the data we were able to get it. And we were, of course, able to reduce the data set to run the experiments and optimize the hyperparameters. And what hyperparameters? Some of these. No, it's the next one, sorry. I'm talking about, yeah. And how we did it, we did it with automated hyperparameter tuning, great search, random search, and some Bayesian network, among others, in order to tune these hyperparameters. We run close to 30 experiments with, as I said, around 30%. And some of the hyperparameters that we tune, it's the learning rate, number of neurons, of course, the number of layers of the neural network, and the learning rate decay. And how we did it, and usually in machine learning, in something, how you split the training and the test is usually something around 60% for training, 20 for testing, validating, and another 20 for testing. But we're talking about big data, or a lot of data that we have. So we could use 90% to train and only 5% and 5% to test and evaluate. And by the way, we use some optimization techniques. A method that we use for tuning the hyperparameters is Adam. We ended up having around 1,000 neurons in 5 layers and a learning rate of 0.0002. And we have something decent, but we also face, what do we need to do to get it better? We had something decent, but not necessarily get it ready to answer in an automated way the questions to the students. We said, no, probably not. We need to see something else. So we checked the learning curves and found that we could improve the bias. What is the learning? How do you check the learning curves? Well, you do a lot of runs on training and testing sets and just change the training set in numbers, and you find some trends on bias and variance, and we found that we were missing some bias. 1 minute? Oh, wow. 1 minute. I thought we had 30 minutes.
You did.
Okay. Then I'm going to have to go very fast. So we found that we needed to add some context because we were failing on bias. And either we create a better or more powerful. We use a more powerful algorithm, but this was okay. But we found that we needed to find context, and for example, to the whole chat. For example, we included, if we were talking about math and a specific topic, we included that context, and that helped us a lot. I'm going to skip some of these. Let me go to the recommendations. Well, some of the conclusions here, it's not everything. It's about the model or improving the model itself, but it's about improving the end-to-end solution. So we want to focus on the solution and who uses and who uses it, and those who uses it give us feedback of this. Well, some things to consider very quick. When to retain, and does it, it does not necessarily work. If it works today, it does not necessarily going to work in the future, because we may probably, or the students and the interaction may be different, the language that they use may be different, and so on. We also wanted to have some controls because we want to talk about privacy issues and things like that. Just as the conclusions here, it's very important to have, in building AI products, experimental and data-centric approach, which means going back into these loops. Experimental and data-centric yields valuable insight and hence the final product. The other thing is, as I mentioned before, sometimes you may see that the model work, but not necessarily the application. So look at type 3 error in statistics. Okay, when your data is good, your model is good, but you're probably not applying it to a good problem, to the problem. And deployment and scalability always built in phasing until go big, and the users of the AI product are the ones who decide the success of it by using these techniques or that improve. Okay.
This is great. Well, good job, Adam. I really like the talk. So, let's give a round of applause. I just almost knocked myself over there.